Okay, now let's talk about subsets. The symbol of subsets is found on its right side. That's subset. Now, do you have any idea what is subsets? If we will go over with the definition of subsets, I don't know whether it is clear for you. So I will just give you an overview of what is a subset. It's just like a municipality of Dumanhog. Now, in a municipality, there are barangays. A barangay is a subset of the municipality. So that's one of the example. Another, in a certain school, say for example, Dumanhog National High School. Now, for example, there is a section Orchid. So a certain section Orchid, is a subset of Dumanhog National High School. Now, let's go over with the definition of subset. Okay, given, there are two sets given, A and B. Set A is a subset of set B. That's the symbol. A is a subset of B. Read as A is a subset of B. If and only if for every X is an element of A and X is an element of B. Now, do you understand this notion? Do you understand this? So it's not clear for you. Now, let's have an example for you to understand. Example number 1. Okay, there are two sets given. Set A, whose elements are apple, mango, guava, grapes. Set B, whose elements are mango, grapes, apple, guava. Now, let's have the first question. The first question is, are the two sets have the same elements? Do they have the same elements? Let's evaluate. Apple in set A. Is there any apple also in set B? Yes, there is. How about mango? Is there any mango in set B? There is also. How about guava? Is there any guava on set B? Yes, of course. How about grapes? There is. So therefore, they have the same elements. So our answer on this first question is yes. Okay, now the second question. Are the two sets have the same number of elements? Do they have the same number of elements? Let's count out. The first the first set is A. They have apple, mango, guava, grapes. There are 4. Set B, it is also 4. So therefore, they have the same number of elements. So our answer here is yes. Now, we had satisfied the two questions. Their elements are the same. The number of elements are the same also. So our conclusion will be set A is a subset of set B because they have the same elements. The same elements and the same number of elements. Okay? So for you to understand further, let's proceed to the next example. Let's have example number 2. Okay. Example number 2. Set C whose elements are red, orange, green, violet. Set D whose elements are blue, yellow, indigo, and pink. Now, my question is, do they have the same elements? So let's have the first question. Do they have the same elements or are the two sets have the same elements? The answer is, what is the answer? Is there any red on D? Is there any orange on D? None at all. So therefore, this question is a no. So the second question, are the two sets have the same number of elements? Do they have the same number of elements? How many elements are there in set C? There are 4. How about in set D? There are 4 also. So they have the same elements. Now, if this satisfies only one question, could we conclude that C is a subset of D? The answer is no. So we could not conclude that C is a subset of D. So our answer is C is not a subset of D because the two sets doesn't satisfy the two question. Because a subset, it should be that all elements of the first set were found on the other set. That's subset. Okay. Now, for further clarification, let's have next. So therefore, subsets have the same elements and the same cardinality. Now let's have the different category of subsets. Category of subsets. Let's have number one, proper subsets. So had you ever heard the word proper in your elementary? Proper fraction. Is it the same as proper subsets, proper fraction? Exactly no. Because subsets or sets is different from proper subsets is different from proper fraction. What is the definition of proper subsets? Okay, proper subsets, if A is a subset of B and A is not equal to B, we say that A is a proper subset of B denoted by A is a subset of B. That's how we are to define a proper subsets. Now, in usual math, some of the math books, they are to write its subsets. They just write its subsets, not proper subsets. Okay, like for example, mm, in a certain school again, there is a section. So a section consists of 50 students. Now this section is a proper subset of the entire population of the school. Means it is a small portion of the entire. Okay, just like my example earlier, in a municipality, there are barangays. Each of the barangay consists of people living there. So those people in a barangay is as proper subset of the entire community of a certain municipality. That's proper subset. Now let's have an example for you to understand. Okay, that's how we are to read. A is a proper subset of B. Set A is a proper subset of set B. Okay, so this means that all elements in A were found in B, but not all elements in B were found on A. Now, do you understand this meaning? All elements in A were found on B, and not all elements on B were found on A. Now, if we compare the two sets, we will say that B is greater than A. But all of the elements on A were found on B. Okay, let's have an example. Example number one. Set A, whose elements are red, yellow, and green. Set B, whose elements are red, yellow, pink, and green also. Now look at their elements, A and B. Try to look harder. There are 3 elements on A, and there are 4 elements on B. The first question is, are all elements in A were found on B? Do we have red on B? How about yellow in A? Is there any yellow also in B? Yes. How about green in A? Is there any green on B? Yes also. And on B there is a pink. There is pink. So B has greater number of elements than A. But all of the elements of A were found on B. Okay. Now, question is A a subset of proper subset of B? Is A a proper subset of B? The answer is yes. Because all elements in A were found in B and not all elements in B were found on A. So we could conclude that A is a proper subset of B because all of the elements in A were found on B. But we could still, okay, second question, is B a proper subset of A? Is B a proper subset of A? The answer is no, because not all elements in B were found in A, and it is pink which is not found in A. So if we are to look back on set B, there are 4 elements. On set A, there are 3 elements. So therefore, B is not a proper subset of A because B has greater elements than A. Now, we could we could still make another notion for this. That's that is B. So we reverse the symbol. And what is that symbol already? That's the symbol for superset. So B is a superset of A. That's superset because B has a greater number of elements. So B is a superset of A. Now, example number 2. So there are 2 sets again. Set X, whose elements are Anna, Elsa, Olaf, Cinderella, Snow White, Belle. Had you, uh, did you know all of these character in set X? How about Y? Set Y, whose elements are Olaf, Anna, and Elsa. Now, my question is, who has or which has the greater number of elements? Is it X or Y? The answer is X. And Y has only 3 elements. And X has how many elements were in X? 1, 2, 3, 4, 5, 6. So there are 6. So the first question, is X a proper subset of Y? Do you know what is subsets? Proper subsets again? Let's review. Proper subsets. A set is a proper subset of another if all of the elements of the first set is not is found on the other set, but they don't have equal number of elements. Now, is X a proper subset of Y? Look at X. How many elements? You have 1, 2, 3, 4, 5, 6. Look at Y. How many elements? There are 3. So, is X a proper subset of Y? The answer is no, because not all elements in X found in Y. Oh? So X has greater number of elements and Y has only 3. So therefore, this is a big no. First question is a big no. The second example, is X a superset of Y? So this symbol is a superset. Is X a superset of Y? The answer is yes, because all elements in Y contains in X and not all elements in X contains in Y. So this is superset. I will let you understand what is a superset. Okay, X is a superset of Y because X has many elements than Y. It contains many elements than Y. Y has only, how many elements are there in Y? How many elements? Let's review. Okay, how many elements in Y? There are only 3. And how many elements on X? There are 1, 2, 3, 4, 5, 6. So therefore, X is a superset of Y. So our answer is yes. So this question is a big yes. Okay. Now, next example. Okay. So, next question. Is Y a proper subset of X? That's proper subset. Is Y a proper subset of X? Let's review. Is Y has lesser elements than X? So let's review. Look at Y and X. Okay, look at Y. So Y has 3 elements only and X has 6 elements. So therefore, Y is a proper subset of X. Okay? Y is a proper subset of X because Y has lesser elements than X. But if we reverse the process, X is a superset of Y. That's how we do it. Okay? Let's continue. Okay, this question is yes. Because all elements in Y were found in X and not all elements in X were found in Y. Now, number 2, category of subsets. Improper subset. What is improper? Still, there is a word in your elementary, improper fraction, but it's different from improper subset. What is an improper subset? An improper subset is that in every finite set, there are 2 improper subsets. Namely, the empty set or null set, the one which we had discussed earlier in a previous video. And the second is the set itself. That's improper subset. Okay. So if A is a subset of B and B is a subset of A, then A is equal to B. So A is an improper subset of B.